it's very nice to be speaking with you.
Thank you.
Let's start by, if you can tell us a bit about yourself and your role at IBM.
Sure, I've been with IBM for about 6.5 years, and when I started at IBM, I used to do J2E development and messaging development. And I think a lot of people over the course of their careers go up the software stack, and instead I've been moving down the software stack. And so I've spent several years now in the Java Technology Center, which is where we build the IBM JVM. And I've done several roles there. I do a lot of performance work on the garbage collector for the IBM JVM, and I also work on performance tools.
Okay. So what's your current area of focus within garbage collection research, performance research, and tooling development?
Really, we're trying to make tools so that users need less in-depth knowledge of garbage collection in order to tune their garbage collection. And so we're trying to make performance really more accessible to users, so that rather than having to be a performance expert in order to get the last little bit of performance out of an application, you can come in with Java knowledge but without detailed performance knowledge and still be able to tune your application.
Okay. So how has the response been to the IBM Support Assistant? Has the release of this purported one-stop shop for support managed to address the problem of low visibility for the tools available to Java folks dealing with the IBM version of the Java Virtual Machine, or JVM?
We've had a really positive response to it because we are such a big company, we're an enormous company, and so we do end up with quite a lot of tools, and they're delivered by quite a lot of mechanisms. And what we've achieved with IBM Support Assistant is, as you say, a lot more visibility for these tools. And so we've found that users who weren't previously aware of a tool, they download ISA, and then once they have the IBM Support Assistant, they can just browse the list of all the available tools and see what's appropriate for the products that they're using and find tools that they might not have otherwise done. And where we're going with it in the future is trying to get better integration between these tools and a more unified interface for the tools. And so instead of tools which don't talk to each other, we're going to get tools which do talk to each other. And so when you have a problem in one area, it can feed through and say, perhaps you ought to try this tool. And the tool already knows what diagnosis you've done already.
Very interesting. So can you also tell us, Holly, in a bit about the verbose garbage collection analysis tool, the EVTK? Are you still leading that project at the IBM Husky practice?
Sure. The first change with the EVTK is it's had a name change. And so it's now called the GC In-Memory Visualizer. But it's still available through the IBM Support Assistant. And I'm not actually leading that team anymore. I've handed over, and so I've still got an advisory role with that team, but development's continuing.
Okay. So how divergent are the GCE and memory models within the IBM Virtual Machine as compared to the Sun generational model and the JRocket generational model?
In some ways, they're very similar. There's quite a lot of unity in terms of garbage collection technologies. Implementation details are different. The performance is different between those implementations. But the core principles of in the IBM JVM, we have a generational model, and we also have a Mark Suite model. And we find sometimes the generational collector works very well, but for some other applications, actually, things go much better with a Mark Suite model. So I think we've got a choice between those two.
Okay. Holly, can you tell us what are the top 3 popular Java performance myths? Can you demystify them for our viewership?
Sure. The first one I'll choose is a garbage collection myth, because I do get very passionate about garbage collection. And that's that garbage collection is a cost. Because in fact, garbage collection can be a wonderful performance benefit to an application compared to manual memory management. And for example, garbage collection can make memory allocation much faster than you could ever achieve with manual memory management. And it can also make memory access much faster than you could achieve with manual memory management, like you get in C. And so because your memory allocation is faster and your memory access is faster, then your application is actually going to go vastly faster than it could otherwise. And I think people sometimes forget this, and they think of garbage collection only as a cost. And so when they're trying to assess the impact of their garbage collection, they just look at the verbose GC and they look at the GC overhead and they say, oh, well, my GC overhead was 10%, and now I've done some garbage collection tuning and my GC overhead is 20%. I must have made a mistake. I need to reverse that. But in fact, sometimes even though the GC overhead is increased, the actual performance of the application has also increased quite a lot because GC does affect things other than just the actual pauses for the freeing of memory. A second myth, I think, has to do with the JIT and how compilation works in Java. I think because everybody knows that compiled code is faster than interpreted code, they think, wouldn't it be nice if Java was never interpreted and if I could just compile my Java ahead of time and then things would go faster than if I had to do this compiling on the fly. But in fact, with dynamic compilation, you get real performance advantages that you can't get with static compilation because the compiler knows everything about your application and it knows what your application is doing and it knows exact details of the hardware your application is running on. It can make optimizations which a static compiler can't, and it can do conditional optimizations, and so it can make an optimization and then if something changes later and that optimization turns out to be invalid, it can reverse that optimization, which is of course completely impossible with a static optimizer. It has to be very conservative, whereas a just-in-time compiler can be a bit more reckless, and then if something goes wrong, it can undo it. And I guess the third myth really is that Java is slow. I think we sometimes still think, well, Java's great, and it gives me all these advantages in terms of development and in terms of scalability and portability, but really it's not very fast. But in fact, because of these performance advantages that you get with the garbage collection and because of the performance advantages that you get with the dynamic compilation, Java can be very, very fast, even compared to more traditionally fast languages like C.
Okay, okay. Very interesting. I'm sure people will learn a lot about it from there. So, how important is tooling to the overall Java performance tuning efforts? To what extent can tools play a role? What do you think?
In an ideal case, if your in many cases, you'll write your application and the performance will be fine and no tuning is required. And in those cases, tools aren't required. But when you do find that you need more performance than you've achieved in your first pass, then tools really are invaluable. And when you have a problem, either a performance problem or perhaps more of a coding problem, like you're using objects unwisely or you're leaking memory, then in these cases tools really can so speed up the diagnosis of the problem.
Okay. Can you also tell our audience what you foresee as the next big breakthrough in Java performance tuning, garbage collection, and thereby improved Java application performance?
Sure, I think we're working in two directions in parallel. One of them is trying to reduce the need for Java performance tuning full stop. And so we're trying to make the JVMs more autonomic. And so instead of having to, on the command line, know all these parameters and try this one and try that one, instead, we're aiming for a model where you need to know less about performance. The JVM will just do the right thing for you. But then in parallel with that, sometimes the JVM, because applications are different and people have different requirements for their applications, sometimes it can't guess what you want, sometimes you make a mistake which the JVM can't correct, for example, if you leak memory. And in those cases, where it's going is increasingly sophisticated tools which, instead of having to have a lot of knowledge in order to use the tools, you can bring up the tool and the tool can make a pretty good guess at what your problem is, and the tool can say, I think you might be leaking memory, and I think this is the object that you're leaking, and I think it's, in this class that it got leaked. Or in the case of garbage collection, it can say, if you did want to improve your response times, you might try these parameters. And again, making performance tuning more accessible, and so that even without really expert knowledge, people can use the JVM and use the tooling and get really excellent results.
I'm not sure how much time you had to interact with the developer crowd in India, but from whatever you've spoken to them and what you have seen, where do you think Java development is headed in India or among the Indian developer crowd?
Up, I think. I was so pleased today when I spoke. I got such a good response in terms of curiosity from the audience and in terms of the questions and in terms of how much hunger there for knowledge there really was in the people that spoke to me. I was very impressed.
So it's been great to have you here, Holly, and it's been a pleasure speaking to you.
Yeah, thank you very much.
Yeah.